Good afternoon. Today I'd like to show a short demo of Artwork's GBRRIP, which is a high-performance RIP designed to handle very demanding Gerber files and to produce very large bitmaps for image writers. So the test file we have been provided is shown on the screen, and it seems to be a number of test patterns that have been rotated and mirrored in different directions. We also noticed that this Gerber file has a lot of internal layers, which can sometimes be a little demanding for a RIP. The computer we're using is running Windows 7, and you can see it's a 4-core i7 running at 3.06 gigs. It's got 12 gigabytes of RAM, but because GBRRIP's a 32-bit application, we really can only use the first several gigabytes. GBRRIP is actually a library. We provide a little executable called GBRRIP that can be used to essentially exercise the library. I run it from a command line, so we start by calling the program GBRRIP. Then we name the input file we want to process. We tell it that it's 274x. We tell it the units of the input file. We tell the program to use 256 megabytes of RAM for the image buffer. And we ask that our output be -pack indicates TIFF in pack bits format, and the file will be called bridge.tiff. We've set a DPI of 5080, which turns out to be a 5 micron pixel size. AW means compute the extents of the data automatically. Anything that follows engine arguments is a special argument, and the only argument we care about here is to tell the program to use 4 threads. We typically use 1 thread per CPU for some of our rasterization processes, which does speed things up. So the next step, of course, is just to execute this program and to see what happens. I'll just execute by clicking rip.bat, and a DOS box comes up, and we won't see anything, so I'm going to pause until we're done, and then we'll look at the results. Alright, the program finished, so let's open up the log file and see what it reports. The log file echoes our command line, and then it begins giving us various informations about the data it's processing. Most of this is for diagnostic purposes should something go wrong. It gives you some concept here of the extents of the data that it computed. It gives you some of the various other parameters and how long some of the various threads took. What we really care about here is what's going on at the bottom, and that's the number we care about. So this whole process took 1 minute and 17 seconds. Produced almost a 200 megabyte TIFF file. Remember, this is a monochrome file, and it's compressed using pack bits. In order to actually look at our results, we use a program that we developed ourselves called Very Large Bitmap Viewer. We developed this because we found that it was actually quite difficult to use existing tools such as Photoshop to look at these large files. So I'm just going to open this bridge.tiff. You can see it opens very, very quickly for a 200 megabyte TIFF file. And now I'm going to have a look around at some of these data just to have a look. And you can see that it looks quite smooth at 5080 DPI, at least for that one. This gives you some concept of the size of the various items. Here's another area where you can look in and see the smoothness. So you see the RIP runs very, very fast, produces very, very smooth results. You can have it RIP anywhere from, a few hundred DPI up to 50,000 DPI, and it makes effective use of multiple processors to get done quickly. Thank you.